Welcome to Peaks to Power, a podcast brought to you by the U.S. Department of Energy's National Laboratory of the Rockies. It's Wednesday, July 1st. I'm Karen Jerriman.
And I'm Taylor Mankel, here again, shocked it's a start to another month.
I know, I feel like we say it every month. Thanks to everyone for starting off this month with us by listening to Peaks to Power.
And why waste any more time? Let's dig into this week's stories.
We hear a lot of talk about critical minerals lately, but how critical are these minerals actually? Well, chances are you rely on them more than you realize.
Yeah, that's right. If you turned on a lamp today, sent a text message, or perhaps traveled via airplane, you relied on materials made from critical minerals.
Right. Critical minerals are key building blocks for technology that we use literally every day. They're also important for the country's economic security. But the supply chains to access these critical minerals are not stable, which is something NLR researchers are working to address.
Ryan King is part of a team of NLR researchers that is trying to find ways to make supply chains more durable using AI models.
I think a lot of it was motivated by the need for more flexibility in the way we approach critical minerals. So it's a lot of these slow-moving industries where the equipment is, you install it and it stays the same for generations. But at the same time, the supply chains are evolving rapidly. A lot of the top, highest grade resources have been used up, and we're looking for ways to make use of lower grade resources or trying to accommodate geopolitical supply chain shocks that maybe change the feedstocks that are available.
They're looking to AI for solutions in mineral processing, solutions that can address supply chain volatility and create more resource flexibility.
Now, Ryan has a background in fluid dynamics and mechanical engineering, and he uses AI to tackle challenges related to complex energy systems and natural resources.
Things like batteries and power generation systems to the function of the entire grid. And Ryan and his team lean on computational science to contribute to the lab's critical minerals research.
Ryan is based in Minnesota, which, as it turns out, is a strategic place to be for this type of research, thanks to the Iron Range in the northern part of the state. It happens to be the largest producer of iron ore in the U.S.
Ryan's location is also convenient for the lab's partnership with the University of Minnesota's Natural Resources Research Institute. We're partnering to improve resource efficiency, natural resource modeling and management, and workflows in iron ore processing.
And AI can potentially help adjust processing steps based on the iron's intended end product, because different applications for iron require different iron purities.
I think a good example of that in Minnesota is all the iron processing was traditionally intended for making pellets for blast furnaces. And when we look at potentially shifting to an electric arc furnace, you have to make a different type of iron ore pellet. How do we do that efficiently and cost effectively with the equipment that these mines already have and with the just kind of the inherent limitations in the iron ore that's in the ground that they're able to extract? So I think a lot of it started with this domain need for accommodating variability on the input side or pushing the limits on what we can do on the output side as part of a sort of a material discovery or push for higher performance materials. And AI is a great tool when you're trying to either build predictive models that you can then turn around and do optimization for design and controls to maybe improve some of the output performance or to handle some of that variability and uncertainty on the input side.
And while iron isn't currently considered a critical mineral, Ryan explains that the opportunities to solve challenges with AI could be applied for any mineral.
In a lot of ways, I think the working with people on the Iron Range has been a bit of a gateway into the larger world of mining and CMM topics around mineral processing and how do we build AI models for all these different unit operations that happen. So there's grinding and crushing and separations, and in a lot of ways, that doesn't matter if it's what the actual mineral is. You're faced with a lot of the same challenges of how do I get it out of the ground? How do I process it? Break it down mechanically to something smaller, separate it, and then do some kind of high temperature chemical processing. So you kind of get experience with all these like very canonical unit operations when you're looking at iron, and then you can turn around and apply that to kind of everything else on the critical minerals list.
Interesting stuff and processes, and with my Iowa roots, I always love the opportunity to spotlight the Midwest.
To wrap things up, we want to give a special shout out to the lab's Geothermal Research Program Manager, Amanda Kolker, and Laboratory Protection Director, David Digon. They were both named fellows in the Department of Energy's Oppenheimer Science and Energy Leadership Program.
Since it started in 2016, the Oppenheimer program has focused on identifying and developing exceptional scientists and engineers who are advancing the U.S. Department of Energy's mission.
Amanda and David were selected for the program's 9th cohort alongside 20 others from the National Laboratory Complex.
The group is currently participating in a year-long series of workshops in Washington, D.C. and at fellow national laboratories.
At each stop, fellows engage with former laboratory directors, leaders at the Department of Energy, and private sector executives who volunteer their time to help develop the next generation of national laboratory leadership.
We're doing tours of key facilities. We're getting briefings from senior leadership at each of the labs that we visit on what their capabilities are, what their issues and challenges are, and what their opportunities are, where they're trying to grow and things like that. So goals for me to get out of this program is really the big picture from like the DOE enterprise level of what each of the labs are doing and what risks they're facing, what opportunities they're trying to exploit and things like that, and sort of how they all fit together in one lab network.
That was David, who leads laboratory protection programs focused on physical security, emergency management, and risk analysis. Since joining the laboratory in 2024, he has helped guide the development of new classified research capabilities and security infrastructure here at the lab.
And the great thing about the program is that I'll have this cohort going forward where any lab, I think every DOE lab is represented in this cohort, and I'll have 1 or 2 points of contact at every lab. So if there's ever a question that I have about, hey, what is it that Berkeley's doing about this problem, I have somebody that I can contact and they can get me in touch with the right people.
As a geothermal researcher, Amanda felt similarly.
One of the things that I got very intrigued by with this opportunity was additional ways to collaborate with other labs. So first and foremost, just learning about the specific missions, but also, detailed understanding of the capabilities of all the labs.
Sounds like it's going to be a great rest of the year in the program.
A big congratulations, Amanda and David, two rising stars in the Department of Energy complex. Well, that wraps another episode of Peaks to Power. We're sharing the latest happenings and highlighting people behind the science at the lab.
We hope you all enjoyed, and thank you for joining on today's episode. We'll be back in 2 weeks with more news from the lab.
And before then, you know the drill. Hop onto that podcast streaming app of choice and leave us a review, please. Or email us questions and ideas to podcast@nlr.gov. This episode was adapted from National Laboratory of the Rockies news articles from June 2026, written by Julia Medeiros-Code and Hannah Hallisker. Our theme music is written and performed by Ted Vaca, and episode music by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC. This podcast is produced by the National Laboratory of the Rockies Communications Office.